Right, now question 15 is winding me up. I've already gone wrong twice in this, and I'm getting rather fed up with it. So we're trying to do the arc tangent, and f of 0 is equal to 0. S dash of x, you've got no problem with that. So that's 1 over 1 minus x squared, which actually gives us a 1 here. Rewrite that as 1 minus x squared all to the power of minus 1 to help us out with the next bit of differentiating. So when we differentiate this using a chain rule, we're going to be timesing by minus 1 and minus 2x. So we've got a 2x coming outside this here. So we've got 2x over 1 minus x squared all to the power of minus 2. But the issue is that's a 0. So that differentiates to 2. This differentiates to 1 minus x squared now all to the power of minus 3. Timesing by the minus 2 and the minus 2x means we get a 4x outside here. So crissy-crossing this, 2 lots of 1 minus x squared all to the power of minus 2 plus 4x times 2x is 8x, 1 minus x squared all to the power of minus 3. Now it'd all be great here because that bit makes 0, that bit makes 2, and I got quite happy that I'd finished there at 2. Problem is, we got to keep going. So rather than keep going here doing another product rule and all the rest of it, what we thought we'd try and do here now then is tidy this up and say that this is 2 lots of 1 minus x squared plus 8x all over the 1 minus x squared all cubed. So notice here, although that was to the power of minus 2, we put 1 there and 3 on the bottom there. So it gives us, on the top here, we've got 8x plus 2 minus 2x squared. And now on the bottom, we've got 1 minus x squared all cubed. So that's that bit there. No, and I'm not redoing it again because 2x times 4x is an x squared. That's an x squared there. Right, so this is 8x squareds there. Take away 2x squareds. So that's why we've got 6x squareds. Add 2 on the top there. I am not redoing it for a third time. Right, okay. So now we're doing 6x squared add 2, which goes to 12x. And we've got 1 minus x squared cubed, and it's positive because I'm doing a quotient rule this time. So that is 1 minus x squared squared times by 3 and times by minus. So I got minus 6x coming out there. So it's those two things times together, 12x lots of 1 minus x squared all cubed minus, but it's plus, 6x times by 6x squared plus 2, 1 minus x squared all squared, and it's all over v squared, which to the power of 6. Oh, it's messier than it was before. So we're going to cancel 2 of these, aren't we? So we got 12x, 1 minus x squared, cancelling 2 of those, plus 6x squared plus 2, cancelling those 2, all over 1 minus x squared to the 4. Oh, I'm getting fed up. Look, we got to differentiate. Tidy that up at the top. If you tidy that up at the top, so it gives just one thing, because you can sort out all the x squareds here. Yeah, we got 36 here. Take away the 12, so I've got 24x squareds. And then I've got 12x here and another 12x here, so I've just got plus 24x, and that's all over 1 minus x squared all to the 4. The issue is, of course, that one's 0. What's that? That's the fourth one, isn't it? And you get one more to go, and the one more to go, that when that differentiates, that actually the fifth one is going to make 24 as it all goes through there.